Hello, dear viewers. Good day to you all. You're welcome to today's class. So the question is, state the following laws of gases. So you have been asked to state 7 laws of gases. The first one is Boyle's law, followed by Charles' law, general gas law, ideal gas equation, Avogadro's law, Dalton's law of partial pressure, and the Gay-Lussac's law. So the follower has requested that we state the law for more clarification. So let me begin with the first one, which is the Boyle's law. I will not only state this law, but I'll try as much as possible to write out the mathematical expression for each of the laws that follows. So let me begin with the first one, which is the Boyle's law. Boyle's law states that the volume of a given mass of a gas is inversely proportional to its temperature, provided the temperature is kept constant. And mathematically, Boyle's law is given as P1 V1 is equal to P2 V2. So that's for Boyle's law. Moving on to the next one, which is the Charles law. Charles law states that the volume of a given mass of a gas is directly proportional to its temperature, provided that pressure is kept constant. And the mathematical expression for Charles' law is V1 over T1 is equal to V2 over T2. Okay, so under Charles' law, pressure is kept constant. So moving on to the third one, which is the general gas law. The general gas law states that for a fixed mass of a gas under any given condition of pressure, volume, and temperature, then the value of PV over T must remain constant. So the general gas law is a combination of both the Boyle's law together with the Charles law. Okay, so mathematically, the general gas law is given as P1 V1 over T1 is equal to P2 V2 over T2. Okay, so now moving on to the fourth one, which is the ideal gas equation. Under the ideal gas equation, 4 quantities are very important to note: the pressure, the temperature, the volume, and also the number of moles. So the ideal gas equation is also a combination of the Boyle's law and also the Charles law, but the number of moles is included in this case. Mathematically, the ideal gas equation is given as PV is equals to nRT. Okay, so moving on to the fifth one, which is Avogadro's law. Avogadro's law states that equal volume of all gases at the same temperature and pressure contains the same number of molecules. And Avogadro's law has a number which is called the Avogadro's number, and this number is a constant, which is 6.02 times 10 to the power of 23 molecules, or you can say particles. So the sixth one, which is Dalton's law of partial pressure. So the Dalton's law of partial pressure states that if there is a mixture of gases which do not chemically react together, so the total pressure exerted by the mixture is the sum of the total pressures of the individual gases that makes up the mixture. So for Dalton's law of partial pressure, mathematically it is given as total pressure is equal to PA plus PB plus PC plus up to Pn, which is to infinity. Okay, so this is the sum of all the pressures. The sum of all the individual pressures gives us the total pressure. That's the Dalton's law of partial pressure. So looking at the last one, which is the Gay-Lussac's law. Gay-Lussac's law states that when gases react, they do so in volume, which are in simple ratios to one another and to the volume of the product, if gaseous, provided that the temperature and the pressure remains constant. So for the Gay-Lussac's law, we may need to have a question to bring out the parameters given for us to solve. Okay, so this is all we have today under the laws of gases, from the Boyle's law to Charles' law, general gas law, ideal gas equation, Avogadro's law, Dalton's law of partial pressure, and up to Gay-Lussac's law. So if you have any question, kindly drop your question in the comment section, and we shall always try our best to take it up from there. Thank you for watching, dear lovely viewers. God bless you all, and bye for now.